the moon is when it's lit by the sun? Just explain.
Yes, well, I mean, again, if you go and look at the official data for the surface of the moon, you know, I mean, I wouldn't use Wikipedia, I avoided that source, but the actual surface temperature on the moon averages 107 degrees centigrade. So that's the average temperature on the surface of the moon.
So that's higher than boiling water.
Right, so 107 degrees centigrade. That's the average, not the maximum, that's the average temperature. So that's 224 Fahrenheit to do the conversion. And somebody sent me a few years ago an interesting link. A chap in Germany actually sent me this link. Said, go and look at the Lunar Rover Vehicle Operations Manual. And this is a public document. It's on the NASA, one of the NASA archives, and you can go and download this document yourself. And it actually gives the specification for and the tolerances for parts of the Lunar Rover system, one of which is the battery. And if you look at this column of data, these columns of data on their own data, maximum operating temperature limit for the Lunar Rover battery is 125 Fahrenheit. 125 Fahrenheit.
Which is in centigrade?
It's going to be about sort of
times by 5, divide by 9, and add 32 or something like that.
Yeah, that's right. It's going to be about 80 or 90 80 centigrade,
right,
something
now,
like that.
Just to make a comment from an engineer, right? I worked for years and years with hardware engineers designing all kinds of different things that would work outside on motorway systems, things in power stations, on railway lines, and when you're designing something, especially if it's going to work outside, whoever's manufacturing the subcomponents, there will be a temperature range that it will operate in, and you would not select that component, and if its operating range was outside of where it's going to be used, and that would be the most standard engineering practice to do that. So for me, that is another smoking gun, Andrew. That they would fit a component, especially at NASA, into a device that specification was way outside its operating range. It's just the most basic of engineering errors.
Right, absolutely. So we have, you know, you can see that right there from their own information is the hardware would not have worked. So yeah, so if the rover could not have worked, then why are they putting out this story that they took up a rover, you know, took the rover to the surface of the moon? And also other people have pointed out, I haven't put it in my presentation, but you can speed up the film of the rover by about a factor of 1.5 times or 2 times, and it just looks like a car driving on a set, you know, with the dust flying up and so on.
And there's another, you mentioned earlier that there's no cooling system on those rovers, which would mean they would be ridiculously hot.
Right.
Okay.
The components would all get very, very hot, you know, and the tyres would get very hot as well. Obviously, the rover can withstand heat and so on, but all kinds of problems like that.
And the same applies to the module that they used to get off the moon as well. That would have it was on the surface for hours.
Right. I mean, I think they were landed for 7-8 hours or something on the first mission. I don't think they were there very long. But I've pointed out to people, I think in this presentation I also make a point of it. If you drive to the supermarket and you're on an asphalt surface, you go in and get some stuff and it's a hot sunny day in the middle of the summer and it's 25-30 degrees, you put the windows up so that nobody nicks anything from your car. You come back to your car after maybe half an hour, whatever, an hour, and you put your hands on the wheel and you're going to hurt your hands. It's going to be.
And if it was 107 degrees,
how did they maintain the internal temperature to something that the astronauts could stand? They claim that they had battery power for the air conditioning. That's the official claim, as I understand it, that the air conditioning within the module was battery powered. But you can compare it to a car, because you've got 3 guys in there, so you're going to have a similar sort of volume of air within the module to a car. You don't have any convection on the moon because there's no atmosphere, so a car can be cooled by convection. In other words, when you start driving the car, the air coming past the car will cool it down. You can't do that on the moon because there's no gas to give that sort of cooling. So you can only cool it by radiation. So how did they do it? How did they keep the lunar module cool? I mean, to me, when I thought about it, I never thought about this years ago. You know, when I believed the Apollo story. How did they keep it cool?
Now, also related to temperature on the surface of the moon, one of the astronauts on the later missions actually placed an object on the moon is for sort of sentimental reasons. Just tell us about that. And you've done a little experiment to try and replicate this.
That's right, Charlie Duke. And what he decided to do is, for because of Mama's apple pie and those sorts of American, sort of cultural ideals, looking at the Charlie Duke photograph. Charlie Duke was one of the astronauts on Apollo 17, I think, or Apollo 16, and he took this photograph of his family with him, and he put it in a clear plastic bag, and he put it on the surface of the moon, and we have a NASA image of that family photograph. In other words, a photograph of a photograph allegedly on the surface of the moon. And I saw this web page 2, 3, 4 years ago, and it said, well, this is impossible because the average temperature of the moon, the average temperature is over 100 degrees, 107 Fahrenheit. And if you have
centigrade,
centigrade, correct, 225 Fahrenheit, so above the boiling point of water. And if you have a photograph, now remember, photographic paper is made of a number of layers. It's got a layer that actually takes the image and makes the image with whatever chemicals they put on there, and have like a card layer behind it to give it some rigidity. And those layers, when heated up, expand at different rates, just like a bimetallic strip in a thermostat would. So this photograph will curl up, and you can show this. All you need to do is get a photograph, put it into an oven, and it will curl up.
And you did that, so let's just take a look at it.
So here we have a family photograph, and over here we have an oven, and this oven is set to 100 degrees centigrade, and I'm now going to put this photograph in the oven. She's cooking some of my dinner, and then I'm going to watch it through the glass. And that you can see that in very short order trying to get better light, but you'll see it when I open it. This is curling up within seconds, so I think that's a pretty convincing demonstration. And here it is. You can see it there, curled up, and that's only at 100 degrees centigrade.
Would it behave the same with air around it, do you think, Andrew? Do you think that
right,
makes
well, I
a
mean,
difference?
that's the question. I haven't done this in a vacuum, so it's not a 100% accurate simulation, but I don't know of any reason why having air around it would
stop it from
curling. Yeah,
right.
yeah. I mean, obviously in this example the air is transferring the heat to the photograph, but in the example of the surface of the moon, the bag was in contact with the surface of the moon, yet it didn't. There appears to be no significant effects on the heat. So that right there, to me, proves that photograph cannot be taken on the surface of the moon.
Right. And you showed an image of a footprint, which is a very famous image,
right,
from an astronaut's boot, which shows very clear, very well defined lines of the sole of this boot, and you would contend that that looks like it's got moisture in it.
Well, this is, again, if you look at that image, it's the iconic image of the first footprint on the moon. I made a couple of observations about this photograph. Remember, these were cameras were mounted on the chests of the astronaut, so he's going to have to bend right over to take a good clear picture of this. They had no viewfinders, but the shot is well framed. So that's one comment about that particular photograph. But the other comment, as you said, is about the impression. If you look at the way that those grooves of the boot are pressed into the surface of the moon, to me, maybe some expert in materials who can correct me on this if I'm wrong, because I wouldn't say I'm an expert on this, but to me, to get that sort of impression, you need moisture to bind those particles together.
So if you were on just a sandy beach with no moisture, it wouldn't leave a print like that.
No. If you've got Wellington boots on and you're on the top part of a beach away from the sea, where the sand is all dried out completely and it's just grains, you don't get footprints like that.
But you would nearer the sea where it's still damp.
Correct. And that looks like that footprint has been made in some type of sand with moisture in it.
Right. All right.
So
and the surface of the moon won't have moisture in it?
Apparently not, because again it's 100 degrees centigrade, so any moisture would have boiled off.
Now, I mentioned in the Channel 5